All right. Ready for this one? Ready? On this problem, it asks us to find the real zeros of our polynomial function, and then also to explain what the multiplicity is. So when we're finding the real zeros, we need to remember that real zeros are the exact same thing as your x-intercepts, and they're all the values of x that are going to make our function 0. So there are values when f of x equals 0. So the first thing I'm going to do is I'm going to plug in 0 for f of x. I'm going to say I need to find the values of my x when f of x equals 0. Whew, so we got a big problem here we need to look at and see if we can factor it. Well, the first thing I always like to do whenever I'm seeing something that has a lot of stuff with it, is see what can I factor out. And I look at this and I automatically know that they all share some x's. And the x to the highest degree that they share is an x squared. So I can say, I can pull out an x squared. That'll leave me an x squared minus x minus 20. And remember, just to double check my work, if I factored out correctly, if I did the distributive property, would I get my exact same answer? And yes, x squared times x squared is x to the fourth. X squared times negative x is that negative x cubed. And x squared times negative 20 is a negative 20x squared. So good, I factored it out. All right. Now the next thing is I say, all right, well this is still in parentheses. Can I factor this out any further? And in my head, I look at this and I say, what two numbers multiply to give me negative 20, but then add to give me negative 1? So these two numbers are going to have a difference of 1. Well, the only two factors of negative 20 that have a difference of 1 are 5 and 4. And since this is negative, I know it's going to be x minus 5 and x plus 4. X, what was it, plus 4? X minus 5. Right? And we could check our work by factoring or foiling that back out and expanding and seeing if it works.
Is that negative x plus 4?
No, that is just markers. Sorry. So now what we need to do is we need to find the zeros. Well, remember when we have something as a set of linear factors, these are all multiplied together to give us 0. So we can write that either 0 equals x squared, x minus 4 equals 0, or x minus 5 equals 0. Therefore, we say x squared equals 0, x equals 4, add a 5 to both sides, x equals positive 5. All right, is everybody good at this point? Is everybody good at this point?
Yeah.
Because we need to talk a little bit about multiplicity. All right, and these, you guys see we have one value for this, right? Our value is x equals negative 4 and x equals 5. So these are what we call having multiplicity of 1. However, this is an x squared. Therefore, it actually has a multiplicity of 2. And this has become very, very important when we're going to look at the graphs of these. But for right now, if you guys can just remember, even if it was written like this, x minus 4 squared equals 0. This is also an example of it having a multiplicity of 2. All right, or one time like we like to say is a multiplicity, an even multiplicity, and these are what you call have an odd multiplicity. And it's very important for that because what happens is when you have a odd multiplicity, this is where at these two zeros, it's going to cross, and at here it's only going to touch and intersect. So we'll get to that a lot more once we deal with graphing. But for right now, what you need to know is you find the zeros by factoring, just like you guys have done before. So really all we're doing is practicing factoring again. And then if you're given any kind of factor and it's squared or to any other even root, it's going to be a multiplicity of 2 or even. All right? And if you can just get a single root or 0, then it's just going to be a multiplicity of 1 or odd. Make sense? So that's all the questions asking. Find the zeros and tell me what the multiplicity is. And we'll get into how that multiplicity affects the graph here a little bit later. Okay? No? You guys look like really scared on that one.